podcast this one. So we've got a water skier whose weight is 155 pounds. So if we know the skier's weight, then we know we can get his mass. Okay, so that might be a value that we need because we certainly use mass in the formula for kinetic energy and in the formula for potential energy. He has an initial speed of 20 feet per second. Later on, the speed of the ski is 37. Determine the work done by the net force acting on the skier. So again, my starting point is KO plus UO plus W. Now let me see if there's more than one W. It looks like there's only one W. They're not mentioning friction here. So the only W is the work that's causing the water skier to speed up. And that's going to equal KF plus UF. So we're on water. We're not going off a ramp. It looks like it's just, they're not mentioning a ramp. So we're pretty much on a level surface. So what can I cancel out? Right, I can cancel out UO and I can cancel out UF. Now I can't cancel out KO or KF because there is an original speed and there is a final speed. And the question is asking, determine the work done by the net force acting on the skier. So if I solve this right away for the work, because that's the unknown, I just have to move my KO to the other side. So my work is going to be KF minus KO. And my formula for K is 1/2 mv squared. I have the two V's, but I don't have the M yet on the board. So I need to somewhere solve for M. So let me do it this way. M will be W divided by G, because W is M times G. So if I want to solve for the M, it's the weight divided by G. So it's going to be 155 pounds divided by what? What should I put for the G? What's the acceleration due to gravity in the English system? Right, but I don't have to put the negative because directions have already been, that if I were putting the negative, the weight is actually a negative because that's down. So I can just put 32 feet per second squared. And what do you get if you take 155 and divide it by 32? So it's going to be 4 point something. 4.84. And what are the units for mass in the English system? Slug. So that's the number that I have to put down. And that does come from the fact that a pound is a slug foot per second squared. So if I take a slug foot per second squared and divide it by a foot per second squared, the only unit left is slugs. So now that I have that, it's just plug into the formula and you have your answer. So I'm going to have work equals 1/2 mvf squared minus 1/2 mvo squared. See if I can fit all this stuff in next to it. So 1/2 mvo squared minus 1/2 mvo squared. So the mass is 4.84 slugs. So I can put that there and there. And the final velocity, the final was 37 and the original was 20. So the final goes here, 37 meters per second. And the 20 goes there. And if you solve that, that's going to give you your answer for the work that's needed to raise the speed from 20 to 37. And that came out to be 2,345. And the units in the English system are, whoops, I messed up. Because I put meters per second, and both of these are feet per second. And I caught the mistake right here because whenever you're doing a physics problem, the unit also should be created from the work that we did. So what I'm going to get here for units is foot-pounds, because a slug foot per second squared is a pound, and I have an extra foot because it's foot squared per second squared. So that's where the extra foot is. Same thing over here. Slug foot squared per second squared is foot-pounds. So your final answer here is that. Let's see if I can bring this down a little so you can see the whole solution. All right, any questions with that? Yes? There could be. I mean,